Good morning, Cardinals. It's me, Mr. Ernst, and today we're going to be talking about how we can solve a system of inequalities with using graphing. And so, of course, we're going to be using graphing. So, of course, we're going to be starting off on Desmos. So I can show you guys a couple of things. First of all, we have a regular linear equation up here. Y is equal to negative 2x plus 1. As you can see the line right here, we have the red line that's kind of coming down. I've got the projector set up and everything like that, so we can see nice, easy line. Nothing new here. Cool? What I want you to pay attention to is when I remove this equal sign and now make it an inequality, I say it is greater than, you'll notice that, boom, it shades in a large portion of this. And the reason for that is because everything in this shaded area is an answer. So beforehand, where it was just a simple line, only the answers on this line, from here all the way up, only the points that were actually on this line, the ones I'm highlighting right now, only these points were the ones that would work in this equation, and nothing else. I could not pick a point over here. I could not pick a point over here, only on this red line. However, when I say it is greater than, we're essentially saying that the answer is greater than the function, which means that we're going to shade in everything above this line. So we're shading in everything over here. That means that not only are my answers on this, or I'm sorry, my answers actually aren't on the line anymore, and I'm going to talk about that in just a second. But the answers to my equation aren't the ones on the line anymore, it's the ones over here in this red area. So for example, if I look at 0 and 6, 0 and 6 is something that would work to make this true. So 0 and 6 would work, 2 and 2 would work, 4 and 4 would work, anything in the shaded area. Now, you might notice that the style of this line has also changed. It went from a solid line beforehand, usually looks like a solid line, but now when I do greater than, it looks like a dotted line. The reason for that, the reason this is now a dotted line rather than a solid line, is because this says greater than. It does not say greater than or equal to, which means we are not equal to this line at all. So basically it's saying we are not on this line itself. We can't be these answers, but we can be anything above those answers. We can't be anything on the line, but our answers can come from anywhere above that line, which is why it's dotted. It essentially says we can't use any of the answers that are here, just over here. If I was to change this from instead of just greater than to greater than or equal to, greater than or equal to, notice now we have a little line underneath. This goes back to being a solid line, and we still have the little red mist thing over here. And that's telling us that, again, we can use now any point along this line as our answer, or we can use any point over here in the wild red yonder for our line as well. Cool? So answers are on the line, or answers are anywhere in this red area to the right. Okay. Just a quick note, if you are trying to do this on Desmos and you need the greater than or equal to sign, if I type the greater than sign and put some spaces in the equal sign, it separates the two of them. Greater than and an equal sign. If I type them one after another, greater than and then the equal sign, it automatically adds them together. So you have the greater than or equal sign. Same with less than, space, equal sign. But if I go less than and then type the equal sign immediately, it gives me less than or equal to. So I'm going to type one more equation in here. Let's do y is equal to, we'll do positive 2x this time. So see, it's starting to create my line, but it's an equal, so there's no shading. Y is equal to 2x, let's say minus 1. Cool. So there's my new equation. We can see the line here, and we see there's no shading yet. It's just a solid green line because it's an equal sign. I'm going to change this. I want to say that it's going to not be all the answers above the line, so not this direction, but everything below the green line in this direction. So that means it's going to have to be less than or equal to. So I did less than or equal to, so notice my green line is solid. Again, it's not a dotted line anymore, it's solid. And then it colors in everything over here in green because anything in this direction could be a solution to this problem. I could pick 0 and 4. I could pick 0 and 6. I could pick 0 and 8. I could not pick 0, 0 would not work. And I could not pick 0, negative 2. Cool? Now, beforehand, the solution to a system of equations, when we were using equal signs, was simply where these two lines crossed, which in this case would be 1/2 and 0. Right? There was only one solution that they shared. The difference now, however, is that if I was to come back over here and plug all this back in, the difference now is, yes, they do share this point still, because they're both solid lines, so we can take an answer on the line, but everything shaded red is an answer, which is everything here, and everything shaded green is an answer, which means that their answers are everything in this red-green area over here. Everything in that red-green area right here. So I could pick 0, 4, and 0, 4 would solve both my red equation, because it's in the red area, and it would solve my green equation, because it's in the green one. So the solution to the system is actually this entire area that has both of them. So let's look at what this looks like on paper now. We're going to switch over to... There we go. So switching over to an actual problem. This is the first problem on your guys' assignment. I'm going to show you guys kind of how to go about doing this, and where did my little color palette go? Give me 1 second. Window and color set. There we go. There's my colors. All right. Cool. So we have two inequalities. Y is less than or equal to negative x minus 2, and y is greater than minus 5x plus 2. You guys had a similar assignment to this last week, and we basically plot these guys out exactly the same, except the difference now is that instead of an equal sign, we have an inequality, which means instead of just a line, we also have to do some shading. So my very first one, y is less than negative x minus 2. Just like beforehand, we need our starting position. We are starting at negative 2. So we're going to start our graph at negative 2, which is right here. Again, we look on the y-axis. We find where negative 2 is. Negative 2. There's our first point. This is our starting point. From there, we have to look at how this is going to change. We have negative x. We know that this is going to have up and down change, or in other words, my change in y, over my change in x, which is my left and my right change. So I have my up and down change already, and because it's not an actual fraction, I'm just going to put it over 1, because any whole number, or any number, can be put over the number 1. So I'm changing my up and down. This is a negative x, so this is going to be going down by 1. This is a 1x, down by 1. And this is left and right. Probably should have said this earlier, sorry. This is negative 1x. So we have negative 1. We actually don't need the x here. That's not a part of our slope. We have negative 1, so we're going down by 1. And then here we have a positive 1, so we're going to the right by 1. So grabbing my little point here, starting here, I'm going to go down by 1, and I'm going to go right 1. Down by 1, right 1. And I can kind of see where my line kind of comes in here. Should be right about here. Bop. So now I have my orange line. However, once again, this is not an equality, it is an inequality. Our answers, y, are all less than or equal to. So this is nice because this is a less than or equal to, so I do not need to make this a dotted line because it is less than or equal to. So anything on the line is still fair game. In addition, this is less than. So I'm looking at my line and I need to go below my line, which is over here, and shade in everything that is below my line. So this whole area down here are answers. Anything down in this area. So in other words, if I wanted to pick, let's say I wanted to pick 1 and negative 4, this point right here. So 1 and negative 4 for this equation. I know it's going to work because if I put y is less than or equal to, I have my negative 1 multiplied by, instead of x, I'm going to be putting in, what point was I using? 1 and -4. I'm going to plug in my 1 value, minus 2, and then for my y value, I'm going to plug in -4, -4, and see if this comes out to be true. -1 times 1 is -1, and then we've got minus 2 is less than or equal to -4. Did that kind of in reverse, my bad. Anyways, -1 minus 2 gives me -3. And -4 is definitely less than or equal to -3. So that is a true statement. So that answer works. I could also pick this answer here, this answer here, this answer here, this answer here. Anything in this orange area is an answer to my top equation. Cool? But we're not done solving the system of inequalities yet, because just like beforehand, I have to graph both lines. So we're going to start on the second one now. Y is greater than or equal to -5x plus 2. Just like beforehand, we have to have a starting position, which is our y-intercept, +2 this time. So +2. And then from here, we have -5 is our slope. Once again, we know we have to have our vertical change, our change in y, over our horizontal change. Because this is not a fraction, I can put any number over 1, so that I can see what my directions are. This is negative, so this is going to be down by 5. Down by 5. And this is left and right. This is positive, so this is going to be right by 1. So this one's going to be much steeper than the other one. So starting at my point here, I'm going to go down by 5. 1, 2, 3, 4, 5. And I'm going to go to the right by 1. 1. And I can see that these two share this point right here, which is kind of neat. And I've got that. So I've got my 2 points here, which means that I can now put a line between them. So I'm going to go down this way first, and then I'm actually going to grab this once more, and I'm going to come right back up through it. So I can draw that as accurately as possible. Bam! There we go. So now I've got my blue line, which is here. However, and again, this is greater than or equal to, so again, my line is going to be solid rather than broken, rather than a dotted line. This is going to be, my answers this time are greater than this, than the actual line itself. This is the line. These are my answers. The answers are greater than. So on my line, I need to go above the line. This one's a little harder to read because it's skinnier, but this side is going to be above it. So anything over in this area gets shaded in. So I shade in this area, and this area, and this area. My lines are not even today. There we go. Just like beforehand. And we're going to see that these guys start to overlap. So we have, now on our graph, we have a blue area. These are all my answers to my blue equation. We have an orange area, which is all my answers to my orange equation. And we have a blue and orange area right here. This little kind of triangle down here is where these guys share answers. This area is both blue and orange. So this area, it's not a line anymore, it's not a single point. This area down here is my solution. Solution. Done. So if I picked any point in this little pink area, that would solve both inequalities at the same time. Again, solving a system means we're looking for an equation that is going to solve both of them at the exact same time. Cool? On your assignment today, you do have a couple of equations that are going to look exactly the same, except they're just going to change these signs around. So these two signs are going to be just a little bit different as you guys are going through and doing that. Cool? Good luck, you guys. Please let me know if you have any questions, and talk to you later.